All right, you should be done with your quiz at this point, and we want to move into section 1.1, chapter 1. We're just basically going to solve typical linear equations, and then we're going to throw in what's solving formulas for a specified variable. So when there's no constants involved or there's more than one variable. All right, go ahead and copy this down. Pause it if you need to as you're working through here. In all these linear equations, you know how to solve every one of them, but every now and then there's just a little, mistake that'll creep in here. We're just going to go over a few of them, and you just got to be careful as you go through these. But solving this one here, we still want to work inside out, working with parentheses. So what I'm going to do is I'm going to distribute that -4 inside here. So I get 3, 2 minus 4x, and then -4 times -1 will give you +4. And this isn't going to affect anything over on the other side. So I'm going to go ahead and do this. And that's going to give me 3 minus 4x. -4 times 2 gives me -8. I like to, and I think it is best, if you simplify everything in the parentheses all the way down. You theoretically could distribute that 3 and not affect the answer, but it just, to me, it leads to more mistakes. So I'm going to simplify everything. So that becomes 3, and I'm just going to make this a parentheses now because we distributed -4x plus 6. Adding the 2 and the 4, and then over here I'm going to combine like terms. I always like to write my x term first. -4x, and then 3 minus 8 will give me -5. At this point, I'm going to distribute the 3. -12x plus 18 equals -4x minus 6. I like to have my x's positive. This goes way back to algebra 1 when I'll say move the little guy. And I get 18 equals 8x minus 6. Add 6 to both sides. Why'd that become a 6? That is not a 6. That should be a 5. Sorry about that. And so now I'm going to add 5 to both sides. And I get 23 equals 8x divided by 8. And x equals, and you're fine just to leave that as 23 over 8. That is absolutely fine. All right, theoretically, we could go back to the beginning, substitute in 23 over 8, but that would be a difficult task. Yes, it has to work, and with your calculators, it's not as bad, but you could always check it. So 23 over 8 is our answer for this one. Now, just some special cases. 6x plus 4 equals 6x minus 2. You might even just look at it and know it's a special case and know what the answer is. But sometimes you just get in the habit of going through the work, and I'm going to do that. I always get the x's on one side, but when you do that, you end up with 6x minus 6x in both cases, which are both zeros. And that leaves you 4 equals -2. Remember, there's not going to be an x left, so don't just make it a 1x. All right, at this point here, you are done. 4 equals -2. That is not true, and this is a case where it will be no solution. Okay, since this is a false statement, that's going to give you no solution. All right, second special case here. All right, this is a little bit more messy, a little bit more terms on each side. Go ahead and distribute. We end up with 2x minus 8 plus 6 equals, all right, -3x plus 5x. I'm going to go ahead and do that right now. It's 2x minus 2. I get -8 plus 6, which gives me -2. All right, at this point, some of you may say, hey, all right, I know what's going on, know the answer, fine. Sometimes you just get in the groove, you keep going. Now make sure you recognize that's going to give you a 0 here and a 0 here. What we're left with is -2 equals -2. All right, what's the answer? You just cannot leave that. You cannot just say true statement. There, you need to state how or what the solution is, and when that is true, it is all real numbers. Any number will work for x. It doesn't matter what it is, because basically each side is exactly the same. Up here, okay, you can never make the two sides equal because you got a 6x and a 6x. All right, now this will be also is referred to the second one as an identity. Okay, identity. And then the first one, when you get a false statement, no solution, that's a contradiction. So there's your special cases. You either going to get all real numbers, you're going to get no solution, or if it's just linear with a single x, no powers, you're going to get a single answer. Okay, a single answer. All right, now solving literal equations or solving formulas for a variable. So in this case here, we got y equals mx plus b. Basically solve it for x. That means get x by itself. Okay, not 1 over x. X is in a numerator. Now for all of these, you cannot have complex fractions, which means you cannot have a fraction over fraction. So I'm just throwing some things out there. You cannot have 1 over y divided by m. Okay, it has to be a single numerator, single denominator. Okay, when we are done. All right, so for this one here, solving for x, you do it just like you would an equation. You add or subtract first. And now you can't actually, subtract them. So you just represent it as y minus b equals mx. And now you divide by whatever's multiplying the x. Whoops, not an x there. It should be an m. An m. And so we got x equals, I'm just going to flip the order, y minus b over m. Now that's perfectly fine. Sometimes you might see people split that up into y over m minus b over m. Those would be equivalent. This would be okay. I think in this situation, just having one numerator and one denominator, a little bit nicer. All right, so y minus b over m. All right, copy down this one here. A minus p equals PRT. All right, now here's the issue. A minus p equals PRT. We were solving it for p. I got to get p by itself. You have two terms with a p. All right. All right. One thing you cannot do not copy this down. Hold on. That is PRT. Some people think if I get this p by itself, I'm done. No, you cannot have two p's running around. You have to simplify everything. So what you want to do is get everything with the variable you're solving on the same side. So I'm going to add p to the side. Now, when I write this, it doesn't matter which one you write first, but I am going to write p plus PRT in that order. All right, here's the trick when you have a formula or expression with the variable you're solving for in more than one term. You factor it out. Treat it as a GCF. So I'm going to factor out the p. And when I divide p by p, you get 1 plus RT. Don't forget, if you distribute it back in, you got to get the original one. That is how you take it from, in this case, two terms. The p occurs in two terms to where it occurs only one time. Get everything with the variable on one side, factor it out. Now you divide by whatever's in parentheses. So those cancel, and I'm just going to write the P first. It is A divided by 1 plus RT. That is an acceptable answer. Okay, that's not a complex fraction. You got a single numerator, a single expression in the denominator. Okay, so you're done with that one. This will come up lots. Okay, this is important that you know how to deal with this. And these next two will kind of cover it again. All right, copy down this. M equals x over y minus 2n. Solve for y. All right, when you are asked to solve for y, you cannot at any point end up with 1 over y equals whatever. Okay, it has to be y equals when you're done. So the thing is, the issue we have to take care of is this y is in the denominator. I got to get it out of the denominator. Well, to get it out of the denominator, you can multiply everything by this denominator. So multiply. Now there are 3 terms. You have to multiply each term by y. Okay, this becomes m times y. Now what happens here is those cancel, and that just leaves you x, and this is minus 2ny. All right, well, we got the variable out of the denominator, and then but now I got a y in both terms. You have to do what we did in the last problem. Anytime we are solving for a variable and it occurs in more than one term, get everything with that term on one side, and then you're going to have to factor. So I'm going to add 2ny. I'm going to add 2ny, and I get my plus 2ny equals x. Now, at this point, factor out the y. It's a GCF. And now I'm going to divide by m plus 2n. And I get y equals x over m plus 2n. Okay, this is not a complex fraction. You have a single numerator and a single denominator. What would a complex fraction look like? I don't know. If you have x over m plus 2n over, make up another variable, z. Like this is a fraction within the example. You would have to reduce that to a single numerator, single denominator. All right, one last one here. 1 over x plus 2 over y equals 1 over z. We are solving this for x. So 1 over x plus 2 over y equals 1 over z. Now you could go a step at a time and get rid of each fraction, or each denominator, but we can get rid of all of them in one step. You can do that by multiplying by all the denominators. So multiply by x, y, and z. Multiply all 3 terms by x, y, and z. So what happens there? The x's cancel. You are just left with y times z times 1. So there's yz plus. Here the y's cancel. You're left with 2 times xz equals, the z's cancel, and I'm left with xy. So I create another scenario where I'm solving for x. I got an x here, and I got an x here. So I got to get the x's on the same side. Probably easiest one here is to subtract 2xz. And I get yz equals xy minus 2xz. Okay, get everything with the variable you're solving for on one side, everything else on the other. Factor out the variable we're solving for, so I get y minus 2z. And now I divide by y minus 2z. And I'm going to write this as x equals yz over y minus 2z. Okay, that'll be it then. All right, so this is section 1-1, page 88, and then 39, 41, 43, 54 through 57, all, and then number 79. Sometimes I will give you the answers to the even ones ahead of time, just so that you can verify them as you're doing your work. Sometimes I'll give them to you the next day of class. I'm going to go ahead and here's 54. Here's 56. You should be able to get all the others from the back of the book. All right, if something doesn't make sense, we'll go over it tomorrow. All right, hope you did well on the quiz, and good luck on the homework.